Okay,
Go
thank
ahead,
you
Becky.
for joining us for the Utah Energy Code and Building Science Lunch and Learn training, sponsored by Rocky Mountain Power, Dominion Energy, and the Governor's Office of Energy Development. My name is Becky Robbins, and today's training is also sponsored by Panasonic. These trainings have led to hundreds of builders, contractors, building inspectors, and others to gain a better understanding of Utah's residential, and will also offer commercial energy code. I also want to thank Salt Lake Community College's Energy Management Program, which you'll be hearing about in just a second, who has helped us put on these trainings. As you'll hear, they've also helped a lot of Utahns find jobs in energy efficiency. Please note the materials for today's meeting. We have our Utah Residential Energy Code Guide. This is a tri-fold brochure, which we also have in a digital version. And if anyone online would like a copy of those, I'd be happy to send those. We are live streaming today, and the participants have received all of the materials besides this brochure and our other event information. We also want to point out we have our compliance path document. This is a document that explains the different ways to meet code, whether with a HERS rater or other avenues, and we have a list of our HERS raters who perform this work and also other energy testing in Utah. Just want to point out we have a flyer here for our May 16th and May 17th training. This is of particular note because we're bringing in a national building science expert, Gord Cook, who many have proclaimed as one of the top building experts in the country, and he'll be doing a training on building science, but also on how to sell the benefits of energy efficiency. So if you haven't registered already, we urge you to, because we're hoping this will be a great event. And the next day will be at Ivory Homes, and there'll be 2 homes, one under construction and one that's finished, and we'll be going over all the different aspects of their home. In addition to that, I just want to let those know in attendance we will have a survey that we'll be giving you at lunch. If you could just let us know what you think about the trainings, because we're always trying to make sure we offer what you're looking for. Other than that, I just want to let everyone know that is online that we'll be breaking at noon for about 10 minutes, and so the live stream will go off, and we will be getting a box lunch and bring that back into the room. I think I've covered all the details. Everyone knows our exit here and where to find the bathrooms, and we want to now pass it over to our partners and sponsors, and we're going to start with Alyssa Kay, the program manager of Salt Lake Community College's Energy Management course. Thank you.
Thanks, Becky. So my name's Alyssa. I'm with Salt Lake Community College and the Energy Institute. We provide clean energy training for careers. So things like solar, energy efficiency, and the power line industry. So we offer an Associates of Applied Science degree in energy management. In addition to that, we have a number of smaller certificate offerings in specific areas of energy. Our upcoming certificates are energy efficient lighting. That one starts May 28th, and it's being taught by really one of the premier lighting designers in the nation. We're lucky to have him here in Utah. His name is Jody Good. And then after that, we'll have our energy accounting certificate starting in the fall. And that certificate really teaches how to account for your energy usage, as well as how to account for the payback period of any energy efficiency improvements that you're looking at. So that's a really great certificate if you're in the business of energy efficiency, which hopefully most of you are. And thanks for being here today. I'm really glad to be able to help out to make this training available because it's so important. So next we're going to hear from Pinnacle Product Sales from Floyd and Wayne Sidaway, and they're representing Panasonic.
Hello everyone, my name is Wayne Sidaway, Pinnacle Product Sales. We're your manufacturer sales rep for Panasonic Ventilation and HVAC. We're helping sponsor the event today. We have some product out front if you guys want to take a look at it with some brochures. I also want to just kind of thank everyone for coming. I'm going to be introducing Brent here. Brent Ursenbach, Mechanical Energy Code Specialist at West Coast Consultants. He's also the ICC Combination Inspector, CBO, and Lead Accredited Professional. He's recently retired building inspector from the Salt Lake County. Previous experience includes 33 years with an HVAC contracting and 5 years as an adjunct facility at Salt Lake Community College. He currently serves on the ICC PMG Code Action Committee, PMG Interpretations and Mechanical Code Division Committee, ACCA Educational Institute Standards Task Team, ACCA Manual ZR Advisory Committee, and the Utah Chapter ICC Code Development Committee. He's also been a past president of the Rocky Mountain Gas Association Board of Directors and serves as chair of the UBCC Mechanical Advisory Committee. Brent has presented numerous classes and seminars on energy, mechanical fuel gas code, as well as HVAC design principles. He received a Bachelor of Science in Sustainability Studies from UMass UWW and is an adjunct instructor at Salt Lake Community College, teaching classes in energy management. So I'll turn the time over to Brent.
Thank you. I don't need that. I've got one on me. Great to be here. It's like you said, I retired Monday of last week, and it's wonderful. Sorry, Gordon, that I left you there at the county, but you get to do it someday. I am, as he mentioned, I've been doing these energy code trainings off and on for, how many years ago did we start the webinars at the Capitol? 2009, so 9 years. And for the past about 7-8 years, the state has been contracting with the county for a portion of my time. Well, they are now contracting with WC3. A lot of you know Chris Kimball and his group. And so I'm working for them, you know, the contract's running through them, so I can continue doing this as I also play a little bit. It's great to be here again. I want you to know that I'm still available for questions. I will not be available every minute of the day. Emails are probably the best because I'm going to try to respond within a day to emails. But there's some days that I'm going to be playing and I'm just not going to be around at all. So you probably won't have a lot of success calling me on my phone. But I'm happy to answer your questions, and the state is compensating me, you know, through that contract so that I can still be available. They think there's some value to that. I'd like to thank these people for their funding, and I need to step back a little bit. That's pretty big, isn't it? Just real quick, a lot of you know this already, but and if I stand over here, I think it probably works pretty good. The International Energy Conservation Code includes residential and commercial code. The residential section in this code is also Chapter 11 in the International Residential Code. So you can have either one, it's the same stuff. It wasn't back prior to 2012, but it's been combined, so it's exactly the same stuff. This is an energy-only code, but because we want to have a standalone residential code, so residential, 1 and 2 family dwellings can all be built out of one book. You don't have to have multiple books. We have the IRC. So if you have this book, you got it covered. And that covers 1 and 2 family dwellings and, of course, townhouses. The code, real quick, is just written. Commercial section has 6 chapters. The residential has 6 chapters. What's new in the 15 code is that requirements for existing buildings have been broken out. And this includes mechanical requirements, which we're going to focus on today. So you don't have to kind of dig through the whole code and find things that apply to existing buildings. Then Chapter 6 in both sections are reference standards. The code requires, and I'm just going to load these up, the code requires a label to be printed for final inspection on a new home that tells you your R values on your insulation, your U factors on your windows, your equipment efficiencies, attic insulation, all those different types of things, and what the heating and cooling system efficiencies were when that was installed. And this is just good information for when someone comes along in future years and we have spray foam and blown insulation in the wall cavities, we have an idea of what's in those walls. As a former HVAC contractor, it would have been wonderful if I knew what was behind all those lath and plaster walls when I was there to do an assessment for adding air conditioning or changing out mechanical equipment. And it's it really should be accurate information. These are the mechanical things that it tells us, you know, our efficiencies and our hot water heating, our duct sealing and such, our duct insulation, those things that are sealed or buried. Okay, the compliance paths, and you have a handout that talks about the compliance paths. And I'm not going to spend a lot of time on these, but I want to touch in the new ERI path or the HERS rating. And we have, I see one HERS rater here. Jeff's over there. Any other HERS raters? Oh, Paulette, of course. Paulette's a HERS rater. We have 2 HERS raters here. And that's the new path where you simply get an energy score for your house. Now, I'm hopeful of the day that every home will have an energy score, because then when you're looking to buy a home, you'll be able to identify how energy efficient is that house. It would be great if, when a house went on the market, that was one of the things that prospective buyers insisted upon, a HERS rating or ERI score for that house before they made the purchase, so they can compare it to other houses. The ERI or HERS rating has the ability to give you a mechanical trade-off.
So say you're doing a plan review, what would be the things you look for ERI?
Okay, the question is, so we're doing a plan review and they want to use the ERI path, right? Is that your question basically? What should you look for? Just like any other compliance method up there, we need to have identified on the plans the expected R value for the, for the walls, for the attic. So the same information should be on the plan. Now, what you'll want to get is a preliminary report. What do you call it, Jeff? Just a preliminary report. If you build your house with this in the walls, this in the attic, with doing the ceiling, methods, the air barriers and everything, we expect it to have a 60 or 58 or whatever the score. If you build it that way, and then we make sure all that information is on the plans, so that when the house is all finished and they do the final assessment and testing, that we have a score that's a passing score.
So if they're basically going to be checking it and verifying it, does that relieve the inspector doing any inspections for that?
No, I don't believe that it relieves the inspector of those things need to be identified on the plans, and I think the inspector should still verify that occurs, that the windows are what they claimed, the insulation is what they claimed. It's not something that we completely take away from the building inspector. And Jeff's probably, or Paulette's not going to be there probably as many times as the inspector is going to be there anyway.
And we're third party.
Yeah, you're third party.
That's the beauty of it, is we're a third party coming in and then just verifying on top of everything else that's been going on. And then we certify an ERI score. And there's an actual sheet that comes with that goes to the building department.
Yeah, it's like any other special inspection. It's kind of like a special inspection. But the critical thing is if someone, and I'm glad you asked the question, because if someone says, we're going to use the ERI or even the simulated performance approach, which is modeling without quite the depth, we just don't say, oh, well, it's going to comply. We still have to ensure that's going to take place. It would be like saying, oh, well, here's our structural plans, and we're going to have special inspection for concrete pours and bolts and welds, so we're not going to look at any of the structural after that. No, we still need to ensure that it's built according to plan.
Now, what about the simulated performance alternative? What would you expect to see, like on
Same thing. Same thing. The difference between the two is the ERI includes virtually all the energy you're using in the building. It includes your appliances and your lighting and everything else. So it's just a little more, gives you a little more flexibility. And in fact, it gives you full credit for your HVAC efficiency where your simulated performance does not. You don't get credit for that. So there's some limits to this, and we see a couple pages of requirements in the energy code when you do that simulated performance approach. Good question. So what's in the residential code? Really, it is a focus on the envelope. However, because we're focusing on the envelope, what are we doing? We're building a tighter envelope. We're limiting leakage in the envelope. The envelope directly impacts two things. It impacts our HVAC system design and performance, and it impacts our air quality inside that envelope. And so as we focus on the building envelope, we still have mechanical issues, including the ducts, the air handlers, filter boxes. We have sealing, insulating, and testing there. We have limited space heating, air conditioning, and water heating requirements. Federal law sets most of those. And because of the way we're addressing that envelope and we're tightening it up, we are triggering some other requirements. So we have two sections in it. We have our climate-specific requirements, and I think everybody in here, or most everybody in here, is familiar with the climate-specific requirements. We have our roofs and our walls, our foundation walls, our basement walls. We have our slabs, crawl spaces, skylights, windows, doors. We have all these climate-specific requirements, and they are different depending on where you're located. Why? Because the temperatures are different, our climate conditions are different. And so the lower numbers, 1, 2, and 3, are more air conditioning dominated markets, and 4, 5, 6, 7, 8 are more heating dominated markets. And being that, then we have more insulation requirements for those cold areas, and we have more solar heat gain and reflective requirements in our warm climates. And then we have mandatory requirements, and these apply everywhere. I get questions all the time saying, well, I'm doing the ERI path, or I'm doing a res check, and so I don't need to do those mandatory requirements. Those are only required in the prescriptive path. That's not true. The mandatory requirements are mandatory. Doesn't matter which path you choose, the mandatory requirements apply. Infiltration control, duct insulation and testing and all that. The code doesn't allow building cavities, but that's been amended out. Just clarification real quick, your little trifold. Anything in red is a state amendment. And your state amendments, I gave you a handout that has all those state amendments identified on the page they are. So you can pan a joist. You can still do that. HVAC controls, we have some mandatory requirements. We have some requirements for pipe insulation, and we have one amended out. Washington County, the people in Washington County pushed to have the requirement removed that so they now don't have to insulate hot water lines that are ran in the slab. I don't agree with that amendment. I think it was foolish, but that's the amendment. Equipment sizing, that's mandatory. We still need to do a manual JD&S. Dampers, backdraft dampers and such are required. And lighting is no longer amended out. 75% must be high efficacy, which really is not very hard anymore because LED light bulbs have come down so far. And in fact, I don't know anybody wants some CFLs that I'm not going to use, because I probably have some downstairs. Virtually every one of those items impacts the home HVAC system. And because as we build a better envelope, our air conditioning size is reduced, our heating size is reduced, our comfort improves. If we don't build a good HVAC system to match that, then our comfort doesn't improve. So everything directly impacts the HVAC systems in the house, including our air quality and our ventilation. So in these handouts in the slides, I have this little green text, and I refer to a section of the code, and this refers to something that is on your little trifold document, your little summary document. And one of the first amendments, which is actually quite a big impact, and it's something that I'm going to build on as we go through. But basically what the code now says is, the code says you will follow this inspection checklist for your air barriers and your insulation, and you will blower door test. That's what the code says. The 2015 code says do this and blower door test your house. Now by amendment, it's either this or blower door test. Now our challenge when you do that, and this ties directly to our mechanical ventilation, Jeff, before we started, mentioned that he did a couple of tests this morning. Is that correct, Jeff? Yeah, and they were all under 3?
One was a little bit lower and the other two were way low.
Okay, so according to the code, everything that he tested today would have to have mechanical ventilation. It would be mandatory because it's too tight for just natural leakage to come in and take care of that. So it should absolutely have that. By amendment, only 2 of them would have to have mechanical ventilation because the testing threshold has been moved. And we'll talk about that a little bit more here in just a minute. But why am I spending time on this? Because the house is tight enough now that, yeah, we're going to have possible air quality issues. We're going to have moisture issues in the house. We are not going to be removing the contaminants that we produce by living in the house from the house, or those contaminants might come from the products we put in the house, whether it comes from the carpets or any other materials we put in the house. Now someone's always going to think, well, why don't we just build it leaky so that it just leaks? Well, because that costs a lot of money to keep reheating air when you have to reheat all the air in the house every couple of hours. And it's really hard on comfort. When you have a leaky house, you don't have good comfort, and people are demanding comfort. So the ventilation that is triggered by that blower door test is an important thing. And for those that are builders and those that are code officials, we need to be really taking this probably more seriously than we have in the past. People don't open their windows. They don't do those things that the code has always assumed they would do. Well, they could just open a window for ventilation. So I don't need to go through all these areas of leaks real quick. I'm just going to load up the list, and these are all the things that we need to address to reduce that air leakage. How many know what the typical air leakage was on a house built 10 years ago? Anybody have an idea? Natural leakage, not blower door testing. Somewhere around 0.35 air changes per hour. That's kind of what we assume doing load calculations. You know, we have a little chart in Manual J that we read through what's a tight house, what's an average house, what's a loose house, or what's semi-tight or semi-loose. And they have those actually 5 criteria defined in Manual J. And So you make an assumption by reading through that list, and it talks about sealing and stuff like that, and the average house, according to that list in Manual J, leaks somewhere around 0.35 air changes per hour. Which means what? It means every 3 hours we leak the whole house, correct? Because we're leaking just over 1/3 of the house full of air every hour, so in 3 hours we've basically leaked the whole house. Now, do we really want to spend that much money to reheat all the air in our house every 3 hours? No, we really don't. And there's houses that leak a whole lot more than that. And that 0.35 air changes per hour, to take it to the next step, is steady, relatively calm conditions, no more than 5-mile-an-hour winds or anything like that. Well, what happens when you have 50-mile-an-hour winds or 30-mile-an-hour winds? Well, the number goes way, way up. And so our ability to keep the house comfortable goes straight down. And that's why we have frozen water lines and all these things when it gets cold. So we want to seal these. We want to seal them up. We can drastically reduce our energy consumption by doing that. You know, as we make the insulation better, if we don't improve on this end, then that piece for infiltration, that piece of our energy expense keeps going up in percentage. You know, it's been running around 1/3 has been for infiltration. Well, if we improve the other 2/3, well, that third grows with respect to your total energy use. So it's important that we address these things. And then all we do is address air quality with the right, correct amount. And we address a lot of other issues when we do that. So we've been seeing this for a while, and I'm not going to spend a huge amount of time on this, but we have a lot of spaces, a lot of locations in our house where we're going to have air leakage. And Jeff and Paulette could get up here and talk for an hour or two on all the different locations that leak in your house. And we're addressing these. We're spraying foam. We're putting weather barriers on the outside, air barriers. We're doing all these things to try to tighten that house up. And invariably, there are different things that happen in a house that might create leaks. And I'm hearing from our HERS raters, some of the places, you know, top plates where the drywall fits against the top plates, we get some leakage through there. We have leakage through all of our penetrations. When we create soffits and stuff like that, we can create cavities that leak. You know, you drop down and your insulation thermal barrier drops down around these fur downs and then goes back up. Well, if we put lids in all those drop downs so that we just have this continuous air barrier across the ceiling, we reduce some of that. So there's a lot of things we can do. And when we look at it logically, we really can't be too tight if we ventilate. Anybody disagree with that? There's no such thing as too tight of a house if we properly ventilate. But we got to properly ventilate. So, as I mentioned, the code requires both. We do a blower door test, we follow this list, and if we follow this list and then blower door test, you're going to pass.
That 3, how does that relate to that over 3.5 you were just talking about?
I don't know, Jeff or Paulette, do you know a formula that we can convert 50 Pascal?
Well, you said it was leaking at 0.35 air changes per hour.
Correct.
But this says we can have up to three air changes, which is
A whole bunch more.
a whole bunch more.
Because of the pressure.
That's the pressure at 50 Pascal, which is about.
I'm glad you brought it up, Gordon.
I get it now.
Why do we blower door test a house? To simulate an elevated pressure so we can find the leaks. If I have a tire that goes flat, and I go out and my tire's flat, I might have, or almost flat, I might have still a little bit of pressure in the tire, not very much, but I'm not going to find the leak until I do what? till I put some pressure in it so I can identify the leak. Well, that's kind of what we're doing in a house. We are depressurizing the house. You know, we're taking it to a negative pressure. You can do it either way. I mean, they both will work. But typically, we take the house to a negative pressure, so we have what? We have 50 pascals of positive pressure being exerted on the house from outside. And from there, we can find the leaks by using fog or your infrared cameras or whatever. And so by elevating the pressure, we find the leaks. The same thing in our duct systems. We elevate the pressure a little bit in our duct systems and we find the leaks. Great question, Gordon. And it's something that confuses a lot of people. And there is a formula, and it kind of changes depending on how big the house is, doesn't it, a little bit? Yeah.
Is there a formula that compares what this leak rate would be in comparison to this kind of thing?
That you can get close to what your natural leakage would be based on that. And in fact, the combustion air section in the code actually wants you to, they have a formula. If you know the natural leakage rate, you can identify if you can use inside combustion air. So I've seen it, and it's kind of an approximation, but we can get fairly close. But really what we're really trying to do is, as Mark, who was here a few weeks ago, how big a house are we going to have in our house? Do we want this big a hole, or do we want this big a hole in our house? Because that's really what is, the tighter we get it, that we reduce the size of the hole. We reduce that size, we have to do something. We have to ventilate. Please.
Since you brought up combustion air, can a house that has combustion air meet these combustion air inlet? I guess you close off the mechanical room and test it isolated, but anyways.
Yeah, can you pass a blower door test with an open combustion air duct? Depends on how big the duct is and how leaky the rest of the house is, but the code now requires that if you have that open combustion air duct, that you isolate it from the rest of the house in that little, create that separate room. And everybody that hates that requirement, I'm here, you can throw crap because I'm the one that pushed it to get it in the code. So by amendment, we can do either. Now these are the what it says in the code, these numbers. And so what climate zones do we have in Utah? 5 and 6 and 3. We have 3 in Washington County. And so by the code, we pressure test everything, and we have to test to 3 air changes per hour or less in all of Utah. Correct? So we have to test, that's the maximum leakage is 3 without amendment. That's our maximum leakage we can have. By state amendment, all climate zones only have to test to 5. So you can leak 40% more, and that's in your handouts. Your 2015 IECC, and it talks about it. And so currently, to be code compliant, if Paulette or Jeff go out and do a test, they have to be 5 or less to comply if they choose that blower door test method. Come next January, it drops to 3.5. So that's a significant change. That's almost where the code is right now. And January 2021, it drops to 3, down to where the code is. Now, I don't remember what it is in the 18 code, but we're not going to adopt the 2018 residential code. So that's immaterial here in Utah right now. So as of today, you can leak more, you can have a bigger hole rather than a smaller hole, and still comply with the code. But this is an option. You don't even have to test if you choose to do this. Gordon.
So they're saying that we have to test to 3 come 2021. However, if it does test 3 to pass,
Yeah, according to the amendments that are in place right now in 2021, you're going to have to mechanically ventilate everything. And I'm going to talk a little bit more on that in my next slide or two. So remember again, in Utah, we can do this test or we can do this. And for everybody, one of the things on here, and I'm just going to bring it up real quick, and I did last time, one of the things here says that all your insulation, all your wall insulation, including rim joist, because a rim joist is part of the wall, must be 6-side enclosed on all 6 sides, which means your rim joist insulation cannot be a piece of fiberglass bat unless you put something over the inside surface of the fiberglass bat. I mean, if you want to cut OSB to fit around that I-joist and then caulk around that and seal that, you can. If you want to cut Hvac and caulk around all those seams and fit that in all of them, you can. Or you can spray closed cell foam in your rim joist, and we have an air barrier on all sides because the foam itself creates the air barrier. So if you're going this path, you virtually have to spray foam the rim joists. You have to make sure your corners are built right. You have to insulate your headers. There's a whole list of stuff here that you need to do if you want to do this list. If you do this list, you're going to end up tighter than the 5. If you do this list, you're going to be the 3 or lower.
It also says you have to seal all penetrations, which means you've got to go around to all your outlets and seal into the drywall.
Yep.
I mean, it's a lot of it.
Seal all penetrations. Yep. Your outlets to the drywall, the wires coming into the back of the box, all those penetrations need to be sealed. Or do a blower door test. So if you don't want to go through, if you don't want to do the blower, if you don't want to spray foam, I'm sure a lot of homes pass without spray foam in the rim. Yeah. Question?
So wouldn't it be like your weather barrier on the outside is like everything on the outside, not necessarily everything on the inside of the wall?
Well, the weather barrier on the outside helps you pass the test. That Hvac or whatever, that air barrier that you put on you. As an air barrier. Yeah, if it's Hvac or similar products that are air barriers, not just weather barriers, and they're sealed off, then you'll pass the test. But what the code says with that checklist, that table, is that's fine and dandy. We still want all these other things, and we have this whole list. So if you want to just put Hvac on the outside and blower door test, you're going to pass at 5 if you do a reasonable job in building the home. If you want to make it really tight, then you're going to follow this list and you're going to blower door test, like the code says.
You're never going to be, have all their cover plates on their electrical stuff.
Well, a lot of that sealing needs to take place, in the outlet, the back of the boxes and everything, prior to drywall. But yeah, it's tough. There's going to be extra inspections if you're going to do that. And, maybe your inspector will let you do some pictures. Maybe you're going to go in and say on final, take off that cover plate, and that cover plate. That's all you'd have to do. Right? We don't have to check them all. I'll be the first to admit that when I go in, we just finaled how many apartments were at Artesian, Gordon? 300 or 4, maybe 500 apartments. When I was walking through, plugging my tester in, I did not hit every single receptacle. I hit different ones in every unit when I walked in. Same thing. We can do that same thing. Good questions. We're understanding what we have. So by amendment, come next January, it's going to have to be tighter if you're going to do the blower door test. And hopefully, by next January, we're going to spend some more time on this, and builders and code officials and everybody will have a little bit better understanding and know what they need to do to make sure they have a tight envelope.
So I see a problem here because typically you see your
The question is, so they do it at final and it tests too tight? Do we make them put mechanical ventilation in? Yeah. And we'll talk about how they can do it, and it's not that hard. And really, this is one of those things. All the HERS Rater friends I have, and I have a bunch of them from across the country, say, once a builder starts doing this, they learn in 2 or 3 houses where they're going to be and what they need to do. And so they might battle the first few. And if you're brand new doing it, I strongly recommend you do that blower door test before carpet and floorings. In fact, probably do it as soon as you tape the drywall.
So you said if you do what's required on that list, you're probably going to be tighter than 3-year changes a minute, but you're not, hours, but you're not going to know that because you're not going to test the house. So now you're going to have unhealthy air in the house anyway, and no solution.
Her question was, so if we're doing the list and we're going to be tighter than 3, but we don't blower door test, so we don't trigger mechanical ventilation, do we have a problem? Yep, we do. We have a big problem. And in fact, several of my good builder friends have told me, you know what, I do blower door testing because I want to know how my house is built. And I found that if I'm below 3, I need to put a humidity sensor in like the bathrooms. Otherwise, I have moisture problems in there. You're going to have some problems, and maybe you're not going to see them. Maybe the moisture is going to be in the walls. Maybe it's going to be that the people just aren't very comfortable and they don't know why they're tired or something, because carbon dioxide, when you have a bunch of people in there and you don't have fresh air, what does it do? It makes you lethargic and everything. So yes, because of the way the code is amended, I actually think the builder probably has a little more exposure, because if he doesn't test and he builds it tight and he doesn't mechanically ventilate, has created a condition that's probably not very healthy. Any other questions? Good question. And that's what I was hoping we'd, when I suggested we do this class, so we could have a discussion, so we kind of get our head wrapped around this concept a little bit better, because you've really kind of nailed it right there. If we think a second, I'll be right with you. If we think a second, as the code is written without amendment, the trigger for mechanical ventilation is 5. We hit 5, we have to. But all of Utah is 3. So what does that mean? That means the code, as written, through that consensus process and all these experts and everything getting together and testifying and arguing about it, have concluded that a house in the cold climates, starting with 3, with St. George area type climates, on colder, all need mechanical ventilation. They all need mechanical ventilation, and it's not just air quality, it's what? It's condensation issues within the walls, it's condensation throughout the house, it's air quality. There's a whole bunch of things. And so what's really a big issue now? Moisture issues. OSB just loves water, doesn't it? So, good question. So how do we mechanically ventilate? I'll tell you right now, this is a wonderful way to mechanically ventilate. And these 3 people right here, their boss, Paul, tells the story. Paul built a really tight house, and he had all kinds of problems when he built that first real tight house. And he had to put in heat recovery ventilators because he had issues with the house. And I'm sure you guys have heard this story from him several times, as I have. But that's a little bit costly. And so we do have some options. And the first option is, so if we test tighter than 3, then we should do it. If you're building to this list, you better assume that you're plenty tight, that you should do some mechanical ventilation. Just for builders, that's really what you should do. you should do something for mechanical ventilation. Now, there's a couple of ways you can do it. The code says you can mechanically ventilate with supply, exhaust, or a combination of supply and exhaust. So what does that mean? Well, the first one is supply. We have our heating system, and in this representation, it's in the attic. And so here we have an air handler or furnace, and we run a duct to outside, and we have a damper that closes down if the system's not in use, so we don't have air leaking in. And we have a damper that's motorized. Well, we have backdraft and a motorized damper, basically. And when the air handler's running, we bring in some outside air. Now, the ventilation requirement says we need continuous ventilation, and we have some ways out of that, but let's start with we have continuous ventilation. So what does that mean? We are always exchanging a little bit of air. We're always bringing in a little bit of fresh air and blowing into our space. So we can do that if we do what? If we have that furnace or air handler running all the time. Well, those involved in developing this code recognize that having a furnace blower running all the time is costly, especially if it's not a high efficiency motor. And so if you choose that option, you have to use a better motor. You have to use an ECM motor. The second option, I'll go into this in a little more in detail. The second option is an exhaust fan. Remember I said we can do supply or exhaust or a combination of supply and exhaust. So exhaust means that we constantly remove a little bit of air out of the space. So you can put in a fan that just runs all the time at the 30 or 40 or 50 or 60 CFM you need for ventilation for that house, and just let it and hardwire it so it runs all the time. And that's a really cost-effective method to do it. Now, I'm not saying that Panasonic is the only one that has fans that do this, but those are the ones that I've had the most experience with. Those are the ones that I've included in my slides. So, and besides, they're out here and they help sponsor part of this. But there are other ones, and I'm not trying to sell Panasonic fans. I'm trying to sell you on a good quality fan can be your ventilation. And it could just be your master bathroom fan, runs all the time at whatever CFM you need. And if it's this or Brown's real quiet one or someone else's real quiet fan, guess what? You don't hear them. You literally don't hear them.
The other thing is when that fan burns out, if there's no way that the homeowner can tell, then you can have a problem.
That's right. When the fan fails, we're not going to know.
So you need a noisy one.
Those noisy fans, can you imagine how long that noisy fan would last if you left it running all the time?
A lot longer than you wanted it to.
Yeah, it might go a week or two, huh?
So if you've got an exhaust fan running continuously, how do you prevent, if the house is going to be negative to some extent, how do you prevent gases coming down your flue or something like that?
It's a pretty small number. The question is how do we prevent backdrafting of B-vents and stuff like that? It's a pretty small number, and in fact, if we're building the house according to code and enforcing the code, those open combustion appliances are isolated from the inside environment of the house because we enclosed them in a room. You know, we really, and most of you know, I'm involved in that code development process. Just got back a few weeks ago from the 21 development, and those are the things we argue and debate. I mean, if you've ever watched it on TV, it's nuts that we spend that much time and have that much passion about these things, but we're really trying to build a code that all works together and that really, as a body of codes, functions well and provides the protections. So, we need to have ventilation, we need to have automatic dampers, and the fans need to meet the efficacy requirements that are in there. These quiet fans just like in furnaces, and Floyd and Wayne will know this, when you buy a variable speed ECM motor furnace, that the power consumption is like 15% or 20%, isn't it, of what a standard PSC motor is. And these are high efficiency motors, so they don't hardly cost you anything to operate either.
I've always told people they cost about the same amount of energy as your doorbell transformer. So a DC motor, they don't draw a lot of power, they're very quiet. And when you walk in your bathroom and turn your switch on, it'll ramp up to the higher speed to really get a hard suck when you're showering. But when you turn off, everybody walks out their shower, they turn the switch off, the fan goes off, and all that condensation builds up, and then they get the paint streaking, they get stuff growing behind the wall. It's a real concern.
Yeah, good points. And I've got some I got some stuff to talk about that. It's important, and when the fan fails, if you're putting in one of these fans that jumps to a higher speed to take care of odors and moisture, you'll notice it if it quits.
Do you know, is it code here that, is it 2.8 CFM per watt, or isn't there a CFM requirement? I don't want to put you on.
Yeah, I don't remember the number.
Yeah,
There is one.
which can only be done with an ECM.
Yeah, in fact, I'm not making an excuse, but you know, I literally have 12 code, 15 code, 18 code, and now 21 code,
You don't need
and try to keep them straight is a challenge. But it's
But it really can't be done by a PSC.
I like that, Jeff. The doorbell transformer could use as much as that fan running on low speed. I need to look that up and make sure he's right, don't I?
It's probably pretty close.
It's probably,
You know, go off of what you were saying on there, DC motor fans, especially from Panasonic. You know, the CFM per watt on that is nearly double of what the minimum code requires. And because they don't use very much energy, you know, you're talking constant ventilation fans, they're basically a DC motor on low speed. They will last, and we don't have failure rates on these motors. They last and last and last.
yeah.
So they're extremely reliable technology, so.
Yeah, these DC motors, these high efficiency DC motors, they running all the time, they last better than if you're turning them on and off anyway. Any motor, we know that motors are better that way. And then we have the heat recovery ventilators. And let's talk about each of them a little bit in detail, but let's go to the code and see what it says. How much air do we have to exhaust? A little less than 1,500 square feet with one bedroom, 30 CFM. We get up to 4 to 5 bedrooms and 3,000 feet, and it's 75 CFM. If it's 4 or 5 at less than 1,500, it's 60 CFM. So we're not talking really big numbers. And generally, we recognize in the code right now that 400, I mean that's kind of an average number. 400 CFM is when we really start worrying about backdrafting vents and stuff like that, correct? Because that's when we trigger makeup air for range hoods. So we're looking at numbers that really aren't that high. Now, if you are big and expensive and you're doing lots of things and you don't want to have that negative pressure, what do? You do balanced ventilation. You put a heat recovery or energy recovery ventilator in and you don't have a negative or positive pressure issue. You have a neutral pressure because you're making up and supplying. So this is out of Chapter 15 in IRC. And I mentioned that you don't have to do it continuous. You can do it continuous, or if you have controls that will run the fan. Now, I know that there's thermostats out here that do this because I had a thermostat that I bought 20-something years ago that had an HRV terminal, and it also had a constant fan thing where I could set it that I want it to run 1 hour every 4 hours, and if the furnace or air conditioner operated during that 4 hours, it kept track of that time, and it just ran the amount to make sure I had some ventilation. Now, it's not really complicated. If you only run it 25% of the time or 1 hour every 4 hours, the fan has to be 4 times as big, doesn't it? If your requirement is for 30 CFM, but you only want to do it 1 hour every 4 hours, then you need to move 120 CFM for that 1 hour. And the code does say we don't want to go longer than 4 hours without doing some ventilation. So that's the lowest, is 25% of the time, or 1 hour every 4 hours. So the numbers aren't real big. And these guys and the other manufacturers have fans that you can basically set close to those CFMs, right? Yeah. You can either set it or control it. So it can run, and this goes back to, I think, what Jeff was just saying. We can set that fan to run at 30 or 40 or 50 or whatever. And when you walk in, either occupancy sensor goes to a higher speed, moisture, humidity detector to a higher speed. Floyd?
A lot of these fans now, we see on the requirement on these mechanical drawings and such, is that they require a countdown. So if you have a fan that runs continually at 30 CFM, you walk in, you turn your switch on, or humidity turns it on, or motion turns it on, brings it up to 50 CFM or 80 CFM. When you leave, turn that off, it requires a countdown of around 20 minutes. So you're still taking that moisture out of the bathroom, for instance. And we see the requirement when we're giving out quotes that they have countdown timers. And these new fans all have that ability.
Yeah, and that is something that the 21 code, we're trying to put in the 21 code right now, is that when you have that jump to a higher speed, that it stays there for a 20-minute period or something like that to continue on removing the moisture, odors, or whatever, and then it drops back down to the lower speed. It's not a whole lot of money to really get a lot of benefit, a huge amount of benefit, especially in the bathrooms. You know, in fact, if I were building a big house today that had multiple bathrooms, and I chose not to do HRV, which I would, but I would put one in every bathroom and have them set at low CFM all the time, and then that jump up. It really solves a lot of problems when you get rid of that moisture. When I participate with ACCA and ICC, everybody's always laughing. Why are you guys worried about moisture? You're so dry out there. We are dry, but guess what? We create moisture by living in a house. And because we get cold, we have moisture problems that are different, but every bit as critical because we have the moisture in the house and we have cold components in our building envelope. Components that get cold, if they get cold, we hit dew point, we condense the moisture out. So our positive pressure, we've really touched on most of this, but continuous or 1 hour every 4 hours. If intermittent, we have to make sure we close when it's not in operation. That has to have an ECM motor in it. This is going to cost you money. How long?
12:15. We're going to break. Is that okay?
Oh, yeah, duh. Lunch. These people want to eat, don't they? Yep, that's fine. So in a few minutes, we'll break for lunch. We'll get your lunches, bring them in here. I'll give you like 10, 15 minutes, and then we'll start back up and finish up. So let's kind of, I was thinking she was saying we're done in 5 minutes. I go, no, we're not done. I got stuff to talk about. When we're doing this, the path to outside, so we're positive pressuring, the path to outside is what? Leakage. We leak air out of the house. That's our, quote, exhaust air, is what we push out by positive pressure in the house. Here's our fan. Continuous operation, or 1 hour every 4 hours, backdraft dampers, same requirement, set at a minimum CFM, jump to a higher speed by one of those three, and maybe they have something else you can do to bump it up. And leaks into the house replace the air that you exhaust. So you get your fresh air in by leakage, where positive pressure, you bring in your fresh air and exhaust by leakage. Then HRV, and we'll wrap up on this real quick. I think most of you have seen it. We have heat recovery ventilators and energy recovery ventilators. Heat recovery ventilators simply recover the heat out of the air we're exhausting and use it to temper or preheat the air we're bringing back inside. They work great for removing moisture. I used them on indoor pools all the time because they remove moisture. But they're not always the best thing in Utah in a home, because guess what you do? You suck the humidity out that you're trying to keep up to a comfortable level. And so we have ERVs that don't bring moisture in from outside or take our moisture out. And we'll just go real quick over through this. So let me go to the next one. So the way they work is basically we have a heat exchanger, 2 fans. One's bringing in cool air from outside in the winter and blowing it into our house. One's bringing the warm air from inside and taking it out. And as it goes through this heat exchanger, it exchanges the heat. Now, they make these in ERV with this type of heat exchanger, and this is an ERV that I'll talk about in just a second. But this ERV, this is a desiccant material, so if you're in Biloxi, Mississippi, and you're bringing in that moist air, the heat exchanger absorbs the moisture and then it's transported back outside. Or if you're here, the moisture that we're exhausting out is absorbed by the heat exchanger and we bring it back into the house. This is a wheel type design where there's actually this wheel that's turning, and it's a desiccant material. So we have fresh air coming in, exhaust air going out. It absorbs the moisture, absorbed into that desiccant wheel, and then taken back outside. That's the difference. Typical installation to do a ventilation system. Here's a 1-bedroom house. Here's a bedroom. Here's a bathroom. Here's a kitchen. You draw exhaust sidewall in the kitchen, draw it out of the bathroom, through the ventilator to outside, bring in some fresh air, and just dump it into this return so it just distributes it throughout the house. I put in these 25 years ago in some homes. I put them in my house that I built back then that I've since sold. It actually is a pretty slick system, but it's going to cost you some bucks. Let's have lunch. Okay, just up there?
Yep.
Let's grab lunch and we'll get going in 10, 15 minutes. Thank you. Any questions? Any questions on this mechanical ventilation stuff that we just went over? You know, the budget, the best economical approach really is an exhaust fan. And if the house is big and spread out, okay, 2 exhaust fans. And just have those running all the time.
Why didn't they just go to 3 or less in 19 instead of wait until 21? Why didn't they just drop a clear in?
It's,
You should spend some time on the hill.
it's there's a building up at the north. If you go up State Street and you just keep going north, and you run into a building where the road ends, you know, in T's. The amendments are made in the legislature. I personally, you know, and that's okay. I mean, everybody has their own opinions, and it's America, and it's great. And I'm not trying to bash. I have some good friends in the legislature. I have some real good, dear friends that are home builders. I was a member of the Home Builders Association for many, many years and donated hundreds and hundreds of hours to the group. But we have some disagreements on how fast or how far the energy code should go, and that's fine. I think the energy code as written is not that aggressive, and it addresses those issues that we've talked about. It addresses the moisture, it addresses the air quality. It helps us with our condensation issues within walls and ceilings and stuff like that. And I think the numbers are sound numbers. I think the 3 is a good number for here right now, and I think the 5 is a good trigger. I've thought for as an HVAC contractor for many, many, many years, I've noticed from 1972, when I very first started doing air conditioning and heating, to 2005, when I got out of it, the swing in the public's demand for comfort. And I mean, and it was huge. And since 2005 moving on, the public expects better comfort than we gave them a few years back. You put single pane windows in right now and you would not have happy people, because that draft, those convective drafts would be upsetting. So, I mean, if I was to build a new house for myself right now, I would shoot for less than 2 air changes per hour. I'd probably shoot for 1, just because I'm a geek about it, and HRV, ERV.
Well, and that brings me back, I mean, on our builders and installers aspect, yes, it's less expensive to do a exhaust-only bathroom fan, but like I just did manual J on a tight house last week, and my biggest heat loss was ventilation. So if I don't put an HRV in, then that takes me from 1.5 tons to a ton or whatever.
Yeah.
So the long-term cost for the homeowner is greater.
Yeah.
To a certain extent. So,
Yeah.
anyways, I just wanted to put that in there.
Yeah. In a perfect world, the public would be educated. They would know what they want. They would come to the builder and say, I want this and this and this, and you'd be happy to provide 0.5 air changes per hour if they were willing to pay for it, correct? If they'll pay for it, that's great. And so, I mean, I completely understand. I made payroll for 23 years of the 33 I was in business, and so I understand what profit and loss is, And
well, I do have another question too. Then this is more towards HERS rating. So is there an effect on HERS rating if you're using exhaust to ventilate versus HRV or something?
To build the HERS score, you have to put in your CFM of exhaust. In fact, if you actually do it to rate the house, you actually have to measure it.
Right.
Part of your final.
But as far as does exhaust only versus balance affect your HERS score? Was that your question?
Yeah, basically, or your Energy Star rating, it would, I assume.
Well, not as much as it should, in my opinion. What do you think? I was messing with it the other day, and switching a home from balance to exhaust only, and it did not affect the HERS score.
Okay.
What did affect the HERS score is the 2 things you put in is CFM and number of watts used. So if you've got an efficient fan, that'll help your score versus an inefficient fan. But switching from balanced to exhaust only did not change the HERS
So
score.
it's not really manual J.
So,
yeah.
correct.
Yeah, what I can tell you that the 21 code, there's a number of proposals that are trying to address that very thing. And they're trying to address that if you have a balanced system and where you're putting the air so that you have, basically so that you're ventilating the house more uniformly than just exhaust in one place and just leaking through wherever, there's actually a reduction in the amount of required ventilation air if you can provide it where you need it, rather than just kind of, I mean, what are we doing when we do just a single fan in a single bathroom? We're relying on, we're addressing the issues in that bathroom, but then the whole rest of the house, we're cleaning the air by dilution. We're bringing in a little, and we're diluting it. Where,
in your bedroom where you're breathing.
and when I installed HRVs, ERVs in houses, we actually ducted them into all the bathrooms and laundry rooms and stuff, so they exhausted basically at source for those locations that we want to do more than just dilute the bathroom. It works better in a bathroom if you exhaust out of the bathroom rather than trying to push a little bit of fresh air into it and have that dilute, right? And so, yeah, I mean, so yeah, apparently it doesn't change your HERS score a lot right now, but there is some motion on that.
So that does not, but I will say that adding ventilation to a home does change your HERS score significantly. So if you show the home with no ventilation and then add the correct, ASHRAE 62.2, it will drop a HERS score 3 or 4 points, which is a lot.
So why does ventilation drop the score? Because it requires energy to heat or cool that air you bring from outside.
Sorry, dropping the score is a good thing. That's showing the house is more efficient.
Oh, yeah, yeah, you're right, yeah. It's a good thing. We do need to have, I mean, bottom line is we need ventilation. We absolutely need ventilation. And if that's the only thing you walk out of here today with completely committed to ventilation, then an understanding and
there's some other duct aspects. Duct using your HVAC system, air flow. There's other options too than what you've shown too.
Yeah. There's some other options there. You comment? No. Okay. I thought I saw a hand over there, but maybe just scratching. Go ahead.
One of those other options I could ask you. I'm installing the motorized damper that's tied into the furnace air handler, but I put a 35. It doesn't work below 35 outside, and it doesn't work above 95 outside. Is there a code problem with that as far as ventilation? I figure they can live.
You mean it doesn't run if it's below 35?
It won't open the damper.
It won't open the damper outside?
Yeah.
Well, it doesn't comply with the code.
It doesn't comply.
Because you need 1 hour every 4 hours.
I know. Well, it doesn't stay that cold for 4 hours.
Yeah. Okay. Good questions. Okay, we talked about this a little bit before, and this is in your little summary handout. Rooms containing fuel-burning appliances. I still remember that where I was at, I don't remember the year exactly, but I think it was someplace around 1985, 1986, when Questar at the time came out and said, we have to bring combustion air into all of our furnaces now. We can't rely on infiltration. We've made the house tight enough that we have to cut a hole in the house. And it just has never made sense to me. And some jurisdictions, as they read the code and they read the sections that said we had to do these different things to tighten up the house, have interpreted that, and I think rightly so, that an open combustion air duct really doesn't meet the code requirements for air sealing. And so the only way you could do that, and jurisdictions back when this first started saying, hey, we got to enclose the room. We got to isolate that combustion air from the wide open, unfinished basement. Because what do people do? They just go and shove a pillow in it. And we have no combustion air. And there's millions of pillows shoved in combustion air ducts, aren't there? And the combustion air duct code was broken. It required huge amounts of air. My house that I'm in now, because it came horizontally, required 2 10-inch pipes from outside. Yeah. 150 square inches total of combustion air because they were coming horizontally. That's completely ridiculous. And if you noticed, I don't remember how many years ago, the fuel gas code fixed it. And for natural draft, natural gas, propane gas, for fuel gas appliances, it's 1 square inch per 3,000. It can be horizontal, it can be vertical, and it's just one opening. And it works, but you still have a hole that's 6 or 7 or 8 inch in your house. And it defies logic. And so what this code change says is basically if you have an open combustion appliance, and this can be a furnace or a water heater or both, in a house being served with an open combustion air duct, you have to enclose it in a room. The room has to be insulated to the level of a basement wall in your climate zone. And I'm the first to admit that that's probably the wrong number. R13 is plenty. It doesn't get that cold in the room because of the single opening. We don't get convection through it really. It just pulls in air when it needs it. But the critical thing is we have a sealed room. And if you didn't even insulate it, it would still work, and you probably wouldn't ever notice the difference. Sealed room, threshold on the door, and weather strip it. And an interior door is fine. I mean, a hollow core door really has a reason, it's probably close to a 0.35 or so U factor on it anyway, so you don't have to have this expensive exterior door. But we just isolate it so that that air, number one, isn't mixing in or making the basement cold when the wind blows. We isolate it. It helps us with our blower door testing. It helps us with everything. And it also solves what? It solves the backdraft concerns that we have by the negative pressures we create in the house, by kitchen exhaust and all those other things, and stack effect and all those other things. So this is basically what it says. It's climate zones 3 through 8, so it's all of Utah. If you have an open fuel burning appliance, furnace, boilers, water heaters, you have to build a room around it, you have to seal it, you have to gasket it, insulate water lines and ducts. That, if the combustion air duct passes through the conditioned space, you need to insulate the duct because it's cold air coming through it. And doesn't apply if you can draw the combustion air from inside the house. You might be able to get away with drawing combustion air from inside the house on a water heater day if you go to the fuel gas code and do the calculation. But you got to do a blower door test to know how leaky the house is to do that calculation. Exception, direct vent. Everybody know what direct vent is? A pipe in and a pipe out. The flame never sees the interior environment of the house. Category 4, direct vent appliances. If you have a direct vent water heater and a direct vent furnace, you don't have any backdraft worries ever, and you don't have to enclose them. Because why? They're bringing their own air in, sealed to the furnace, and exhausting sealed to outside. And in fact, the 2018 code that we are not going to consider adopting next year by the legislature, guess what it says? If you use all direct vent appliances and you have no open combustion appliances, the requirement for makeup air for a range hood goes away. You don't have to provide makeup air. Now, if you put in a 1200 or two 1200s in one of the big houses you guys build, you're going to want to put some makeup air in anyway because you're not going to be able to get enough air.
So we don't have to tell the contractors that though, right?
Well, we're not adopting the code. I would not be surprised if that is amended into the code, into the 15 code. It is 2018. Direct vent furnaces first came out in about 82. And I mean, there was a little bit before, but that's when we first came out with the 80, 90%, furnaces that were, really big, starting to come into the market. And so, yeah, Pulse, and then everybody else came out with their condensing furnaces. So we've been a lot of years that we've had this technology, and they've been improved and everything, and it's really time that we put direct vent. And while I'm on that, for the builders in here, please don't let your HVAC contractors just run the one pipe. Because if they just run the exhaust pipe, you have to build the room. If they run both pipes, you can get out of building the room. If you've addressed your water heater. Any questions on that? I'm just going to load them all. Okay, mandatory requirements. So we've touched on a few of these, and since we're talking mechanical, we have requirements for heat pumps as far as supplementary heat, and we'll go into detail on these. If we're using a boiler, we have an outdoor reset requirement We have requirements that apply to ducts outside the thermal envelope. We have ceiling requirements that are mandatory no matter where the duct is, and we have insulation requirements that are basically prescriptive. You just do it on all of them. HVAC piping insulation, this would be mechanical piping like boilers, or if you had chilled water or something in a residence. And then we have some hot water, your potable hot water. We have some requirements on our water heating. Ventilation, we've talked about a bunch, and dampers, equipment sizing. If you do, for instance, build, and I don't know of anybody that's going to do this, but if you had a multifamily townhouse project that had, central chiller, central boiler, and you paid your utility expense through your homeowners, you would revert to the commercial code for that, because that is not typically a residential application. And I can't imagine why someone would want to do that. Snow melt system, we have some controls, and we have some requirements for pools. So thermostats. I am not going to, I'm going to be completely candid with you. I never did a final inspection where I went and verified that the thermostat was programmed per the requirements in the code, or verified that the factory setting was 70 and 78. That's what the requirement says. I think everybody's building thermostats to that. Do you guys sell thermostats? No? There's probably no money in them anymore, is there?
There's the professional line of thermostats that a lot of people will still buy.
Yeah.
I rep a line out of Boise that I don't rep down here, that they're strictly professional thermostat only.
Yeah.
They're not sold residentially. They're
Yeah.
like
Quite honestly, setting back and setting up in a residential application, the better you build the house, the less impact they make on your energy savings. And in fact, my programmable thermostat is not set the way that the industry suggests. Guess what my thermostat does at night in the summertime? It doesn't turn up to a higher set point. It turns down because I like it cooler when I sleep. No, I like it. She can put all the blankets on, but my air conditioning turns down at night. That's not the, quote, energy savings, but it doesn't cost a lot for it to run at night when it's cool. So, that's what the code says. Programmable thermostats are inexpensive. I have this whole thing that takes me 20 minutes to show you that setting your thermostat up and letting your house get hot in the summertime wastes energy rather than just let it maintain when you're not home. Because trying to cool your house down late in the day, in the heat of the day after your house has gained all that heat, it's not going to cool down. Sorry, it's not going to happen. But that's what the code says. This is a good one. Outdoor reset or outdoor temperature setback. Basically, if you're running a boiler, you do not need to run as hot of temperatures when it's 40 outside as you do when it's 10 outside. And so outdoor reset simply has a control with a sensor outside that communicates with your thermostat, your boiler, and everything. And as it's warmer outside, it reduces the boiler temperature. And it's been around forever, and it's really important if you're having radiant heat, because if you're running the hotter temperatures, you overshoot when it's mild. And so what does everybody have to do? They have to open the windows because the house gets so hot that, and so it just modulates water temperature based on outdoor temperature. That's a good requirement. We have a change, and you expect changes coming forward on duct insulation. The only change is that if you have a duct that is smaller than 3 inch, like you would have in a high velocity system, the insulation only has to be R4.2. That being said, everything else is the same, our 6 in a crawl space, our 8 in an attic. There is a huge movement towards burying ducts in insulation in attics, and it's a good one. The only thing better is get it out of the attic, and it'll save a ton of money. Now, some of you have heard this before, but I'm going to share it again because it's kind of one of my soapbox issues. If you have, and this is especially Washington County, Larry's close to it, he's in Cedar City, but if you have a furnace and all your ductwork in your attic down in Washington County, if you have a $300 cooling bill, you're doing really well. Is that accurate? Because $400 and $500 is very common down there. By having your duct in the attic, somewhere between 25 and even 50% of your cooling expense is to overcome the heat in the attic, or heat gain from the attic into your duct. So what is that telling you? If you have a $300 cooling bill, your bill goes up $300 in the summer, and I came prepared this time. I don't normally carry this, but I want to make the point. So you have that $300 power bill, and if your duct was in the attic, you throw one of these away every month. And if it's a $600 power bill, you throw 2 of these away every month. Anybody want to do that? Seeing the $100 bill really drives it home, doesn't it? Would you want to take this and drop it down the toilet and flush it? Well, that's what we're doing when we're sticking ducts in hot attics and we're not burying them in insulation and we're not insulating them even a little bit better. R8 insulation, is that very much? We have no R8 requirement anywhere in a wall or a ceiling or anything, but yet we're using R8 when we have the greatest temperature difference. I mean, heat flows because of the insulated value and the temperature difference. What's the temperature difference in our house? 70 inside, 10 outside, we have 60 degrees temperature difference. 100 degrees outside, 75 degrees inside, we have 25 degree temperature difference. 150 degree attic, 50 degree or 55 degree air on the inside of that duct that just has R8, we have 100 degree or 95 degree temperature difference. And so we have a huge amount of heat transfer simply because our temperature difference, or our delta T, is so high. We really, if you want to save money, if you want to build a home and approach that net zero, get that HERS score down in the 30s so that you can throw on a modest number of panels and be net zero, you got to get rid of some of these things. Getting that stuff inside the envelope will do more to save energy than just about anything else we do.
You haven't even talked about leakage into an unconditioned attic.
Yeah, and I haven't even talked about the leakage if you have duct leakage in an attic. When I first started inspecting in 2005, first inspections I went out on that had ductworks in attics, I says, where's the ladder? I got to get up and check it. Oh, well, we don't worry about the leakage in the attic. Well, that's the worst place. We're doing a real good job sealing the duct in the basement, but we're not sealing the duct in the attic. I look across the street from my house. We have 13, well, they're about 6, 7-year-old homes now, 5, 6, 7-year-old homes. And they all have a furnace in the attic. And when it snows, you can see the end of the attic that has the furnace, and you can see where every boot is in front of a window because we have this little melted spot in the snow right above that boot for the duct system, because there's no insulation on that boot other than what got blown over it. That's dollars going out the roof. And some of this stuff isn't hard.
That manual Jab mentioned this 1,200 square foot house. I ran one simulation with ducts in the attic and one in conditioned space, and it went with the ducts in the attic. I remember the cooling load went 32 to 14,000 BTU.
It went in half.
Oh, yeah.
Yeah, more than 50% reduction by getting it out of the attic. So duct insulation is one thing, but there's a real move in the hot climates that if you have exposed duct in the attic, that it's going to be R24 or something like that. Now that's going to be a pain in the butt to insulate to R24, isn't it? That's going to be, get it out of the attic. And guess what? You can be innovative and clever. Some of you heard this before. I've spent quite a bit of time in St. George. The one builder down there put scissor trusses all the way across the whole house, and then comes in and puts drops in the entry, drops in the laundry room, drops in the bathrooms, drops in the hall, so you don't have these big, tall. And we walked through a house, we did a blower door test on one, we did a duct blaster test on one that wasn't sheetrock yet, and they could have put the furnace was over the garage, so that if it froze and leaked, it didn't damage inside. It was over the garage with duct coming all the way in, and the laundry room was more towards the middle of the house, and there was a 6x12, 6x15 cavity above that drop ceiling in the laundry room. All they did is put a lid in it. They could have put the furnace in there, and they could have ran duct below the bottom of the trusses to the whole house except for one bedroom, and a soffit above the cabinets would have got that one to that bedroom. The whole thing could have been in the house. And looking at it, it would have been cheaper for me to do it that way as an HVAC contractor because I wouldn't have had as much material. It was more centrally located. It wasn't long runs from the garage all the way to the other end of the house. Think about those things. See if you can get some of those inside the envelope, because we can, and we do drops anyway sometimes just for the effect. Duct sealing. And duct testing. So we got to seal all the ducts, and we have to test it if 35% of the duct is outside the thermal envelope. Some people are still enforcing 50%. The code says if you have duct outside the thermal envelope, you have to pressure test it. The amendment says it's 35%. Next January it goes to 20%, 25%, and then January 21 it goes to 20%. The duct needs to be tested. Sealing, and this one's going to change. Basically, it doesn't matter where the duct is, it has to be sealed. If it's in the attic, you should really make sure that duct is tight, because not only is it that heat transfers like like he mentioned, it's if we leak 100 CFM out in the attic, guess what? That's like an exhaust fan throwing 100 CFM away, but we just barely spent the money to heat or cool the air. Or if our return's leaking, we're sucking what, 140 or 150 degree air into our system. So it's really important that those are sealed. The 15 code says that you're supposed to seal the longitudinal or the long joints on snap lock duct. That would include 6-inch pipe, all your snap lock rectangular duct, snap lock rectangular duct. If the machine isn't adjusted right, you can get a fair amount of leakage out of that snap lock. 6-inch pipe, I'd actually like to put a couple of 100 feet together and take it up to, well, 25 is your test pressure, but I'd like to take it up to 50 or even 75 and see how much leaks in the snap lock if we sealed everything else. That actually goes away, I think in the 18 or 21, I can't remember. Troy.
So the gores on a gored 90, each one of those is about 3 to 5 CFM. So a lot of what I see a lot of is on a gored 90, you've got mastic on one end, mastic on the other end, but there's like 3 joints in the middle of it that I seldom see mastic on. And each one of those, each 90, about 5 CFM. So just add up a system and you're kind of above code just with your 90s.
Yeah, and those that have worked with HVAC, sheet metal, those 90s, they're built loose enough that you can turn them.
If they're tight, you can't use them because they don't move, they don't turn.
I'm sorry?
If they're built tight, you can't turn them.
Yeah, if they're built too tight, you can't turn them. And if they get a little bit of sand or something in them, they don't turn. But they're built loose enough to turn. And yeah, they leak as much there as they do on the crimps.
Yeah.
Jeff?
The newer ones have like lubricant in them to make them turn easier, but it also helps seal them.
Yeah.
So that you pay a little more for them.
Yeah. But you should, I mean,
But a lot of times, guys are still not sealing, on the top of the plenum, the drive they put in, they don't ever get there and seal it. It's the hardest one to put in to get it even bent over and everything right in the first place. Then if they don't seal it, they leak like crazy. And after you're all done, to get up there and try to seal those things off, it can be rough.
yeah. I'm going to share, and I know I've said this before. I've put thousands and thousands of systems together. And I know where they're going to leak. I build radius throat fittings, so I didn't have those sharp 90s that you have a bunch of leaks at anyway. But when you build a system, and I had some of my systems tested clear back then. Big leaks where they hook a coil cabinet to a furnace. Big leaks where they hook the plenum to the coil cabinet. And guess what? Those are flat mating surfaces. They have flanges. Would you go home and tear your lawnmower apart or your car engine apart and put it together and then smear sealer on the outside of it and hope that it doesn't leak oil? No. You put gaskets in it, don't you? If you do high pressure commercial duct systems and use duct mate or some of those things, you create flanges and you have those flat mating surfaces. In 1983, when I started my HVAC business, because I didn't like walking into furnace rooms in the summertime and they were ice cold, we put a bead of high temp HVAC silicone down on the top of the furnace, set our coil cabinet on it, screwed it, put another bead, mated the plenum down on it. There's a lot of things that just take this much effort as you're putting it together. Those places that are hard to seal them as you're putting them together. And they work, don't they? It's not really hard. But we need to be looking at that. I mean, I had a guy screaming at me because he smeared the sealer and you could see the holes still. Well, you're being picky. No, seal the duct. Now, yes, it is inside the thermal envelope, but guess what? We want the air where we designed it to go. Mine's a 2-story home. My furnace is in the basement. I don't want all my air conditioning air leaking into the soffits in the drops in my basement. I want it upstairs at the top floor where it's hot. And I take a thermal camera and guess what? My fur down drop in my basement is 55 degrees when my air conditioner is running, because I got enough leakage up inside that sheetrock that it's virtually the temperature of the air coming out of my air conditioning system. Duct leakage. This has also been amended. And what they do is what we call a duct blaster test. And these gentlemen do those. And I think I have a slide in here. Let me jump ahead. Yeah, here's a furnace. They have a little plate that they tape on the blower compartment. You have a fan. And you mask off all your registers and grills. And you pressurize the duct system. You only take it to 25 pascals, not 50, like you do the house. And you pressurize the duct system. And you simply, it measures how much air it takes to maintain that pressure in the duct system. And the leakage has been, the allowed leakage has been doubled by amendment. So your total leakage just has to be less than or equal to 8 CFM per 100 feet of conditioned floor area. If you test without the air handler, it's 6. So these were the numbers before the code was adopted. but the 15 code actually says 4 and 3. And these also phase in beginning in January. Guess what? We don't have to do this if all your duct's inside the envelope. If you have 35% or more of your duct outside the envelope, you should be pressure testing it. And those of you that are inspectors should be requiring them to pressure test it. So if the air handler, furnace, or 35% of the duct is outside the envelope, you have to test your duct and ensure it doesn't leak. Do you still have them fail? All the time?
Sorry, I shouldn't laugh out loud at that. Yes. Not since yesterday.
You haven't done any tests today.
Yeah, exactly. But one thing that's interesting is I got a call from a builder. He says, I've been building this city for years, and my code inspector just for the first time said, duct leakage test. So if you're not doing them now, you're gonna have to start doing them. It's being enforced more and more. It's not less and less. So I guess I would recommend, and this guy, he got blindsided by his inspector. It was late in the afternoon, and he said, I think he was trying to close the next day. And he said, no, I'm not going to give you your final inspection until you've got your duct test done. So best to be ahead of the curve. And if your HVAC crews aren't used to having their stuff tested, they don't know where it leaks. They don't know how to do it right. Best to be ahead of the game, start getting them tested so that you don't get blindsided like that.
Yeah, it's a big deal. It really is.
So most houses have multiple furnaces. Would that just be per furnace?
Test the system that has 35% of the duct or the air handler outside the thermal envelope. They don't have to test the ones that are completely inside.
No, but if they say, well, I've got 2 furnaces and less than 35% is out.
No, per system, per system, per system. Yeah, per system. You can pan joist, but if you have a furnace, like in an upper closet on a 2-story with your duct in the attic and a little bit of return running underneath, and you pan joist, that one's going to be a hard one to get to pass if you're panning those eye joists. Hard to get them sealed. I'm going to wrap up. We started a few minutes late. We're 5 minutes after. I'm going to try to wrap up in the next 5 minutes or so. Mechanical system piping, we need to insulate that. If we have a circulation loop on our hot water system, we need to insulate that entire loop. And mechanical ventilation, we have to have dampers. Piping, insulation, if it's exposed outside, we have to address that, protect it. I did want to make one quick comment on this. The mechanical code has said you have to have R4 insulation on your air conditioning line sets. The energy code says R3 by definition of the temperatures and stuff within the gas. Most line sets come with R3 on them. Don't make someone tear it off or add insulation to it. The main purpose of that insulation on the line set, the refrigerant lines, is condensation prevention. That's refrigerant coming back to the outdoor unit. It's already done its cooling. The only thing it's trying to do is provide some cooling to the condensing unit, the compressor itself. That is going to be fixed in the, I think it's fixed in the 18 code, where it's just R3. In fact, we're trying to take the insulation requirements out of the mechanical code and put them all in the energy code rather than blindsiding someone.
Is there any impetus, or has it been taking place? Is there a requirement to UV protect the outdoor insulation?
There is that requirement, and a lot of manufacturers are starting to make UV resistant refrigerant lines. And that is a requirement in the code. Sizing, I'm not going to spend any more time other than I'm a firm believer in sizing. I learned to do manual J calculations by hand in about 1974. And I guarantee you, if you do a proper load calculation, it'll work. And you'll put a properly sized piece of equipment, and it'll work well, and people will be comfortable with it. There's your boiler outset outdoor reset controls. That's what they look like. If you're venting bath fans out of the soffit, they have to have a backdraft damper in it. And I saw a whole bunch of these one day when I was doing inspections, and they're just little cheapies without a backdraft damper. So look up in there and make sure it has a backdraft damper. And the last thing I wanted to hit on real quick, the code says even if you don't mechanically ventilate, that you have to have a minimum 50 CFM fan for the bathroom, and it actually says you're supposed to have a 100 CFM fan in the kitchen. And we're not enforcing that, but for starters, the bath fan, that cheap fan, does not move 50 CFM when installed, period. No 3-inch fan, and I've searched and searched and searched. I cannot find a 3-inch fan that'll move 50 CFM at 0.25 inches of static pressure, which is the code requirement. So if you were to find a 3-inch fan that moved 50 CFM, we have a table now in the code, and it says if you want to use flex duct and a 3-inch fan, you can't do it ever. If you want to do smooth wall duct, you could put 5 feet of 3-inch pipe on that fan, but you have to take 15 feet for every elbow you put in it. So you can't do that either. So you have a 50 CFM fan or an 80 CFM and you have to move 50, you could put some flex duct on it, but 56 isn't that long if it's doing this, because you have to add up all the elbows in that snake that's running across there. This is in the code. If it's smooth wall pipe, then you can get a little more length out of it. An 80 CFM fan, you can only put 4 feet of flex on it. If it says NL, there's no limit. So if you only want to move 50 CFM and you have 5-inch, you can run it 100 feet if you wanted to. This is out of the IRC. It's well known that those fans don't work. I mean, I've taken just a little strip of toilet tissue and tried to get the fan to hold it up there. It won't even do that. They're $13, but that's all they're worth is $13. They make a little noise, but that's all they do. Real quick, and I just want to, there is a standard now for heat exchangers that you wrap around. They're built as an assembly that go in your drain lines. I'm not trying to say don't buy one, but seriously, how much heat are you going to pick up off your drain line in your house, and will you ever recover enough to pay for the hundreds? And I don't know what it would cost to put that thing, but it'd be a bunch. There are some things where they put heat pump things where they recover heat off main sewers in streets, but spend your money on things that really make a difference, like sealing your duct.
I think the reason to do one of those is more if you have a instant hot water, where so much of your capacity depends on the incoming temperature of the water.
Being up a little bit.
Bump that up 5-10 degrees, can give you an extra gallon or 2 per minute of hot water. So that's kind of what
there might, kind of a preheat.
Yeah, preheat
Yeah.
the water going into your tank.
I looked them up, they were pretty expensive.
Yeah. They used to be exclusively a Canadian thing, but you can get them at Home Depot now, I think.
Yeah.
They're expensive.
Okay. Well, they're available. Anybody that knows anything about heat pumps, if you have a air-to-air heat pump with electric strip heat, you have to have an outdoor stat that keeps the strips from kicking in unless you absolutely need the strips. And snow melt controls, if they put in snow melt, you have to have the sensor in the control, period. They have to put the cup in the driveway, they have to put the sensor on it that senses air temperature, slab temperature, and moisture. So it's not running when it doesn't need to be running. Fireplaces need to have tight-fitting doors. We have some requirements for pool boilers. I'm not going to go spend any time on it. And we have some requirements for pool covers. And the last thing I want to touch on is if it's a historic building, an old house, you do not get a pass on meeting the requirements of the energy code because of the historic building anymore, unless what you're doing is going to threaten or degrade the historic nature of the house. If you're changing the furnace, if you're putting in new ductwork and it's going to be concealed, it has to comply with the current requirements. No, you don't have to change the windows. In fact, you would want to leave the windows for the historic nature, but if you open the cavity, you have to insulate it. You know, that's a change. And if you repair a furnace versus replace a furnace, repairs, you don't have to comply. That's it. Thanks for your questions. We had some really good questions and some good discussion on ventilation. Appreciate your attendance. Those of you that are online, if you have suggestions for a future session, if you like these lunchtime sessions, give us your feedback. Thanks, and we'll see you next time.